A 4-story wall of water that only rises once in 1,300 years was recorded off the west coast of Canada. Some people blame waves like this for disappearances in the Bermuda Triangle. Rogue waves can get strong enough to sink container ships and oil rigs. The Canadian water monster didn't hurt anyone, but it did become a sensation. And it looks like we're about to see even higher and more powerful rogue waves in the future. The team of Marine Labs, the company that operates the buoy that got caught in the Euclid wave, couldn't believe the data they saw. A huge force came out of the blue, pulled the buoy down, and then set it up to a peak before taking it even deeper. They thought it must be a rogue wave, so they sent the data to a scientist at the University of Victoria who specializes in these beauties. They analyzed the data and confirmed it was indeed not a technical mistake. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Scientists have reported seeing giant waves coming out of the blue for centuries, but no one really believed them. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got in a terrible storm and saw several waves over 98 feet tall. It's almost as tall as a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and shared what they saw. But back then, scientists were sure waves couldn't be taller than 30 feet. Everyone took their story as a tall tale. Unintentional. Over a century later, a cargo ship, the MS München, mysteriously disappeared. People believed it to be unsinkable, just like the Titanic, so it was a real shock that all that was left of it was one lifeboat. When experts analyzed the damage, they concluded that it must have been hit by a wave that was around 65 feet high. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This monster on the North Sea that was 84 feet tall hit the Norwegian gas platform Doppler on New Year's Day. It was twice larger than the wave surrounding it. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. The wave wasn't like any other type of wave they'd studied before. So they had to admit rogue waves were real and gave them an official definition. It's a wave more than twice as tall as others around it. It can pop up lightning fast in a stormy sea, or show up out of nowhere in calm waters. These waves have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters trying to do their job. In 2007, America's National Oceanic and Atmospheric Administration made a list of 50 historical maritime tragedies that were most likely caused by rogue waves. Some of the events on the list happen not in the open water, but in lakes. Lake Superior has something that's got the name Three Sisters. It is a series of 3 large waves, one after another. The second wave covers the ship's decks before the first one is gone. The third wave jumps in and adds extra water. These 3 sisters overload the ship. There's a theory that this phenomenon took down the freighter Edmund Fitzgerald in 1975. There are 2 main theories trying to explain how rogue waves happen. First, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. When these waves cross paths, they team up and become stronger to turn into a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they exchange some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and put in a math model that would create a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but there is a huge progress in this direction. Scientists from the University of Melbourne went on an expedition to Antarctica and found out that strong winds play a big role in the creation of rogue waves. It looks like they're caused by a mix of strong winds and the random way waves move and interact with each other. This idea was tested in labs before, but now they've proven it happens in real oceans too. To study these waves, the scientists use special 3D cameras. These cameras work like human eyes, taking lots of images in a row to create a detailed 3D picture of the ocean surface. It showed that rogue waves happen more often when waves are young, which means they're just starting to form and are more affected by the wind. When strong winds blow over young waves, they make the waves taller, longer, and faster, but not evenly. Some waves steal energy from nearby waves and grow much bigger, which is how rogue waves form. The scientists noticed these giant waves happened about once every 6 hours. They recorded no rogue waves in calmer seas, when the wind doesn't have as much influence. Scientists are concerned that rogue waves may happen more often in the future because there's more energy in the atmosphere and ocean. It looks like rogue waves can be much more powerful than scientists ever thought. They managed to create the famous Doppler wave in a lab for the first time in 2018. This helped them study these mysterious waves up close and showed that their secret is in how they form. We think of waves rolling gently on a beach, but the waves in this study happen in open water when waves from different directions meet. When waves come together from far apart directions, they push the water upward, creating what's called a partially standing wave or a crosswave. This can happen when two seas meet, or when wind directions suddenly change, like during a hurricane. The study found that the bigger the angle between the meeting waves, the taller the crosswave becomes. Normally, when a wave breaks, it forms a white foamy top, and that's where it stops growing. But if a wave is formed by water coming from many directions, it can keep growing even after breaking. These special waves can grow to be twice as steep while breaking, which is already much bigger than normal waves. And if you add up all the growth from waves coming together, they can become 4 times steeper than what anyone thought was possible. This discovery could change the way we build things, like wind turbines or oil platforms in the ocean, to make them safe. Right now, many designs don't fully account for these huge multi-directional waves. Now, they seem to have a lot of similarities, but rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. On January 14, 2022, residents of Anchorage, Alaska, heard a series of loud bangs. They didn't stop for a half an hour. As they found later, the source of the bangs was almost 6,000 miles away, in the Tongan archipelago in the southern Pacific Ocean. The Hunga Tonga underwater volcano abruptly woke up from its sound sleep. It last erupted at the end of December 2021 after several years of inactivity. Hunga Tonga sent a large plume of ash into the stratosphere that was seen in the capital city of Tonga, 43 miles away from the volcano. In the following days, it was emitting steam and gas to the height of 7 miles. Plus, it was letting out ash that accumulated next to it and even made the island on which it was standing increase in size. Then, it went back to sleep, and the officials even announced it was dormant. But just a couple of weeks later, it woke up again with a crazy force. It sent ash clouds 12 miles into the atmosphere. It blocked the sun in some places and rained down from the sky. The sound waves from the eruption traveled around the planet several times. People in Fiji heard a sound that reminded them of thunder. Some booms even reached Canada. Shockwaves went around the Earth 4 times in Japan and Utah, and at least twice in Massachusetts. The eruption caused tens of thousands of lightning flashes. It also triggered a mega tsunami hundreds of feet high. It caused damage to buildings and infrastructure, such as underwater cables. The extreme waves traveled all the way to the California coast, and there was an unusually high tide along the Pacific coast of Canada. Scientists studied seismic data to understand what caused such a massive eruption. Their research models showed that there was a big blast, likely because gas got trapped in rocks, like how a pressure cooker works when it's overcooked. This blast released a huge amount of energy, as much as 5 of the biggest underground nuclear tests. It all happened under a shallow part of the sea, where gas-filled rock was trapped. Now, normally when a volcano erupts, the fumes cause a temporary cooling effect on the Earth's surface. But Hunga Tonga's eruption was different. It didn't produce many fumes, but released a massive amount of water vapor, equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned vast amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its long-term effects on our weather patterns. This is because the only way to measure stratospheric water vapor is with special satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. In fact, the Tonga eruption is the most well-recorded blast of its kind in recent history. Scientists had lots of tools to study it, like satellites that took pictures from space and sensors that listened to the vibrations and movements in the Earth. There was a similar eruption in 1991 at a volcano in the Philippines, but back then, they didn't have as many advanced tools as they do now to study it closely. Experts from different countries looked at satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and of course, what this would mean for the planet and for all of us. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. But Hunga Tonga ended up with just a minimal effect on global average temperatures, at least for now. Let's just hope it won't repeat the story of Mount Tambora volcano in present-day Indonesia. Over 2 centuries ago, in 1815, this bad guy interrupted and caused the year without a summer. In the following year, the winter was unusually cold and wet across Europe and North America. There were also some catastrophic tsunamis, destroying homes that took 10,000 lives and 80,000 more who fell ill in the aftermath. Now, you can't miss an event like Hunga Tonga or Tambora eruption, but some underwater volcanoes are discovered by accident. A passenger on a commercial flight looked out her window above the Pacific Ocean and saw a weirdly colored patch on the water. She thought it could be an oil slick or a floating pumice raft, which is a telltale sign of a recent volcanic eruption. She decided to send a photo of this scene to a geologist. And that's how scientists found one of the largest volcanoes in the world, Havre. It's hiding about 3,000 feet below the surface. In 2012, Havre had a massive eruption that lasted about 90 days. Hot lava poured out of 14 different vents around the volcano's semicircle-shaped opening. Havre is just one of many volcanic systems covered by thousands of feet of water. These volcanoes are the most active on Earth and are part of a giant system called mid-ocean ridges that stretches around the world. This system produces about 75% of all the magma that comes out of Earth's volcanoes each year. It releases over half a cubic mile of lava. When the magma cools down, it forms the edges of new ocean plates, which are like giant puzzle pieces that make up the Earth's crust. A team of scientists studied material left on the ocean floor by volcanic eruptions from the Bronze Age. About 3,600 years ago, a volcano that was partly underwater in the southern Aegean Sea woke up with a bang. This eruption destroyed the island of Santorini and sent massive amounts of ash, rocks, and gases into the air. It left behind thick layers of ash and rock that settled in piles on the ocean floor. Scientists have been studying the ancient Santorini eruption for several years to figure out what happens during such massive ones. Their research helps explain how future volcanic eruptions could affect the weather on our planet. The study also helps scientists understand the strength of the eruptions, how high the eruption columns might go, and the sizes of the waves that form when all that ash and rock settles into terraces on the ocean floor. This information will help predict the dangers of future eruptions. Now, when a volcano erupts, the last place you want to be is inside it. But scientists did it for you. Well, kinda. They produced a smart new imaging technique that uses the best ideas from medical imaging and optical telescopes. Matrix imaging, that's what it's called, makes it easier to understand what's happening underground, even when there aren't many sensors available. These sensors, called geophones, detect and record the movement of seismic waves, which are vibrations that travel through the Earth. By studying these waves, scientists can learn about the distinct types of rocks and how they are arranged beneath the surface. The researchers test their method on a volcano in Guadalupe in the Caribbean Sea. There aren't so many geophones on this site, but the scientists combined the data from multiple geophones thanks to this new tech. They used a special trick called the memory effect to reverse the distortions that happen when seismic waves bounce off different underground materials and figure out what the original signals look like. The researchers could clearly see the structure inside the volcano down to a depth of about 6 miles, with incredibly detailed images in a resolution of over 300 feet. They found out that there are many layers of magma stored underground. These layers are connected to other deep parts of the Earth. Knowing about these layers and how they work could help scientists make better guesses about when a volcano might erupt. If they can do that, they might be able to warn people earlier and keep them safe from dangerous eruptions. Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, they noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river, but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the U.S. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States like the Klamath and San Joaquin all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle megafloods. So, the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called evulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of evulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, the other doesn't need to be as strong for an evulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain's steepness and the river's flow to predict where the river might move. They tested it on 10 past evulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used two kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems together.
It's 2010. You're in the Japanese waters of the Pacific Ocean, about 745 miles south of Tokyo and very close to the island of Iwo Jima. The sky is clear. There are almost no waves. A heavy, low rumble comes from somewhere deep under the sea. It scares away all the flying gulls. And then it gets quiet. Too quiet. It seems that even light waves don't dare to make a sound. Suddenly, a small bubble rises to the surface of the water. Then, thousands of air bubbles start moving up, one after another. The water begins to boil and heat up. Its temperature is so high that you can cook eggs or pasta in here. The boiling area grows to the size of a stadium. A huge amount of steam is released into the air. You can see an outline of some huge object through the boiling water. Then, everything stops. The water cools, the amount of bubbles goes down, and the surface of the ocean becomes calm again. That year, an underwater volcano erupted at that specific location. Fortunately, it didn't bring any serious consequences. In August 2021, the eruption repeated. But this time, everything wasn't limited to the bubbling water. The Japanese Coast Guard reported strong volcanic activity in the region. Hot steam and gases came out of the water and rose into the air to a height of 10 miles, which is about twice the height of Mount Everest. The huge awakened volcano began to slowly lift to the surface. If you took a helicopter ride above this place, you'd see more and more land coming out of the water. This is not just a volcano, it's a whole island in the shape of a horseshoe. And this is just the beginning. Seismologists say this island is the tip of a huge volcano. It fills the sky with smoke and ash. The air temperature is rising. Scientists continue to monitor the situation. They believe the volcano can completely get out of the water. Nobody knows what consequences this may have. This isn't the first island that has appeared in the waters of Japan. Underwater volcanoes have erupted several times over the past century. One of the most surprising cases occurred in 2013. That year, a small piece of land was formed next to the already existing island. The underwater volcano that emerged from the water began to grow slowly. At some moment, it connected to the island. After 2 years, the area of this island increased by 12 times compared to the original size. Smoke is always pouring out of this place, and its surface is filled with red-hot lava flows. The volcano is unstable and isn't going to calm down. Such phenomena occur not only off the coast of Japan. In the 1960s, a volcano awoke on the southern coast of Iceland. For 3 whole years, it was coming to the surface, and it formed an island by 1967. They called it Surtsey. Unlike the Japanese islands, this is where the volcanic eruptions ended. Now the island is one of the most inaccessible places on the planet. Only a few scientists in the world have permission to walk around this place. They want to learn how the plant and animal life of the island are formed without human intervention. This is a unique event, and here's why. Underwater volcanoes differ in their behavior from land volcanoes. They don't explode and don't release lava flows upwards. A huge amount of water above them creates high pressure. As soon as the magma gets out, the water immediately lowers it to the seafloor. Underwater eruptions don't normally cause any changes on the ocean surface. So, millions of gallons of lava sink to the bottom, cool down, and solidify around the volcano. This lava forms a thick layer of Earth's rock. To make an island appear on the surface, an underwater volcano needs a lot of magma. The next eruption creates another thick layer. Millions of years pass, and passive lava flows form mountains. Constant eruptions increase the height of the seabed. Layer by layer, the cooled lava rises higher and higher, and then, one day, it appears on the surface in the form of an island. Often, underwater volcanoes don't reach the surface and fall asleep forever. Such volcanoes are called seamounts. The tectonic activity also affects the formation of islands. The volcano has a source of magma that comes from the mantle of the planet. The tectonic plate is moving, and a volcano is placed on it, so the plate can lead the volcano away from the source of magma. When a volcano rises, it can simply move aside and no longer erupt. From the outside, the volcanic islands look like an apocalypse, lava spraying in different directions, smog and ash filling the sky. But in fact, volcanoes are not about destruction, but the creation of new life. Lava is any hot metal, but the natural lava flowing out of volcanoes is called magma. When it appears on the surface of the ground, various gases and acids instantly evaporate from it, and magma becomes lava. But underground, it's magma. These molten metals contain trace elements of almost all chemical substances that exist in nature. They enrich the land they're flowing in. Ash is also filled with many different elements. The lava hardens, the ash settles, and this creates favorable conditions for the appearance of a rich ecosystem. It can take millions of years to develop, though. The simplest bacteria appear. They feed on chemical elements coming from the volcano. When you have favorable conditions for bacteria, you get favorable conditions for bigger life forms. Birds flying by also help to develop the new ecosystem. They build nests on the island, bring tree seeds and plant spores from the continents and other islands. All this enriches life on the volcano. Volcanoes are isolated places, so unique species of animals, insects, and bacteria can appear only there and can't be found anywhere else on the planet. However, if the volcano wakes up, it can also destroy the ecosystem. The entire island can be covered with ash and simply lose all vegetation. But then, on the scorched ground, life can appear again. Hundreds of islands around the world appeared because of the eruptions of underwater volcanoes. Hawaii, Indonesia, and Iceland have them on their territory. Imagine that people settled on a similar volcanic island and built a city there. And one day, the volcano woke up. It once happened 200 miles south of Tokyo. People built a beautiful town right in the center of an active volcano on the island of Aogashima. In May 1785, the catastrophe began. That day was sunny, and no one could imagine what tragedy was approaching them. At some point, thousands of birds took to the air and flew away from the island. Then, the ground began to shake. A heavy, low sound came out of the town depths. Streams of smoke were coming out of the crater of a green volcano. The volcano was throwing dirt, large stones, and various debris into the sky. The disaster lasted for several weeks. Since then, more than 200 years have passed, and the volcano has never woken up again. The town was rebuilt after the disaster. Now, this place is so great, people don't want to leave, despite the risk of a new eruption. More and more residents are coming to the island. There are many thermal springs, and the waters around the island are rich in fish. But the volcano may wake up at any moment. Fortunately, meteorological and seismological services monitor the situation. A lake can also form inside the volcano, but you shouldn't swim in it. In Indonesia, on the island of Java, there's a volcano with a crater inside. It's filled with turquoise water. The magma inside the volcano consists of many molten metals and chemical compounds, and the lake gets these substances. The volcano emits sulfur dioxide gases that combine with the metallic lake. This gives the water its strong acidity and turquoise color. The steam coming from the lake is acid. When it combines with air, it ignites. This is visible at night. Sulfur accumulations flare up and illuminate everything around.
This sleek, state-of-the-art submarine named Ran was sent to explore the depths of Antarctica. But as soon as it discovered something, it mysteriously disappeared. So, what happened? It all started when scientists wanted to explore one of the most remote and mysterious places on Earth, the Dotson Ice Shelf in West Antarctica. This ice shelf, silent giant, stretches 30 miles wide. That's almost the length of New York City. It stands between two icy promontories, the Martin and Bear Peninsulas, and it hides an entire world of geological mysteries. If you think that Antarctica is nothing but a desert of super thick snow and ice, you're wrong. There are entire landscapes hidden deep down there. The underside of the Dotson ice shelf is a rugged, dynamic terrain shaped by the slow, relentless forces of nature. There are towering ice formations, deep troughs, and bizarre structures stretching for hundreds of feet. Scientists are super curious about it, but as you can imagine, this landscape isn't easy to explore at all. To find out more, we have to scan the area with satellites or try drilling through the snow, trying to collect the big picture, piece by piece. But these methods only gave us vague hints. The real breakthrough happened when scientists came up with the idea to let the submarines explore it. Autonomous submersibles could swoop deep into the icy waters beneath the Dotson ice shelf and tell us what's up down there. These robotic explorers have fantastic advanced sonar systems. It's that thing that bats or dolphins do. They can use sound to see the world. Basically, they send out sound waves underwater, and when those waves hit something like the ice shelf above or the seafloor below, they bounce back to the system. Animals feel how long it took for the sound waves to return and how they changed. And this helped them understand what's located where. For example, clicks that dolphins send out tell them where the fish are. We copied this crazy evolutionary trick and adapted it to our underwater exploration. Only our version is much cooler, with a higher level of precision, so we created detailed maps of the environment. The Rand submarine was one of those robotic explorers. It was named after the Norse deity of the sea. Ran had been meticulously programmed to navigate a treacherous landscape of Antarctica. But even with all this training, its journey led to an unexpected and eerie end. In 2019, Ran was sent to explore the depths beneath the Dotson ice shelf. It was a hero, the first one to go on a mission like this. The team said it was like seeing the other side of the moon. For 27 straight days, it worked tirelessly. It traveled over 620 miles beneath the thick ice. That's like a journey from Paris to Berlin. Ran went further and deeper than anyone could have imagined. At one point, it reached over 10 miles into the glacier's belly, and what it discovered down there was astonishing. Scientists thought there would be some smooth, uniform ice surfaces, but Ran revealed an underside marked by huge cracks, ridges. There were formations that looked like sand dunes, frozen in time. And finally, it found some mysterious swirling and teardrop-shaped patterns. They all looked more like art than geology. This actually tells the story of ice shelves and the ocean around it. Warm water sneaks in under the ice and melts it from below. Sometimes it smooths the ice out, but other times it carves out these weird, uneven shapes that look like patterns and drawings. And some of these shapes are huge, over 1,300 feet long. That's about 3.5 football fields. The reason why they look like swirling doodles is because the Earth spins. It makes the water turn in special ways, bending the shapes and drawing these spirals. It's called the Coriolis effect. Imagine you were on a merry-go-round and tried to throw something like a ball. It would go in a curve, not a straight line. Same thing happens with the water on Earth. Later, scientists found similar patterns in other Antarctic ice shelves, though they weren't as epic as the ones under Dotson. But Ran also discovered something horrifying. Turns out that these warm waters, aside from being great artists, are also a huge danger. The Dotson ice shelf isn't just hanging out serenely on the sea. It's part of a very delicate system and acts as a protective barrier that holds back huge glaciers in West Antarctica. The ice shelf is floating on the ocean, but it's still connected to the land. As warm water sneaks underneath it and the ice melts, the Dotson can't hold on to the land as tightly anymore. The protective barrier starts to weaken, and this lets the glaciers behind it move faster into the ocean. When those glaciers flow into the sea, they add more water, which could cause sea levels to rise, eventually changing our coastlines. Rand stumbled upon huge pockets where the ice was melting at alarming rates, all due to powerful underwater currents. It was like seeing a ticking clock on the glacier. The stakes were high, but luckily the submarine was ready. This time, it managed to return. And then, it worked for 5 more years, helping scientists with tons of useful data. The missions were daunting. There could be periods where RAN slipped into the pitch-black cavity beneath the glaciers, spending 24 hours without communication. But it was mapping every peak and every valley. It gained experience from over 40 missions below ice. Then, in early 2024, RAN went on a mission to the Thwaites Glacier. The mission was bold from the start. This place is also ominously referred to as the Doomsday Glacier. It's called that because it's slowly melting and has the potential to raise sea levels worldwide if it collapses, causing catastrophes everywhere. That's why RAN was dispatched to explore its underbelly, a place that had never been mapped so intricately before. The idea was to uncover the glacier's secrets, study how rapidly it was melting and why. This was RAN's second time exploring Thwaites. During the previous visit, it became the first sub to ever map the glacier's underside. RAN was exploring the depths from 650 feet to 1,650 feet. It sent a lot of data about how the Doomsday Glacier was slowly melting due to warm ocean currents. But while venturing into these icy depths, something went wrong. Out of nowhere, RAN vanished. Without warning, without a trace. One moment it was sending back crucial data, and the next, it had slipped into the abyss. No distress signals, no final transmission, and it didn't return to the point it was supposed to. People sent extensive searches, helicopters soared overhead, drones buzzed through the frozen skies, but no sign of the submersible emerged from the glacier's grasp. After a while, RAN's batteries would certainly run away. So at this point, it had definitely been swallowed by the abyss beneath 1,500 feet of ice. That was a huge and sad loss for the scientific team. The scientists at the University of Gothenburg are now looking to replace RAN and continue their important research under Thwaites. To this day, scientists have no idea what happened to it. Some say it may have been trapped in the ice. Others believe it was pulled away by an unseen current. It also might have collided with something unexpected. Whatever the truth is, its disappearance has left scientists stunned, and it looks like the ice shelf will hold on to its secrets a little longer. At least we gained a treasure trove of knowledge from RAN's journey. Scientists keep exploring Antarctica, looking for history that hides under the snow. For example, they discovered that around 90 million years ago, a lush temperate rainforest thrived near the South Pole. They revealed an ancient world far warmer than they ever imagined. Deep in Antarctica, they unearthed fossilized roots, pollen, and spores preserved in the soil. All this shows that there was a swampy rainforest that flourished despite months of polar darkness. All these discoveries changed our understanding of Earth's climate, both in the past and the future.
Did you know there's a guy who rode on a wave for 7.5 miles? It was accomplished by Brazilian surfer Picarutas Salazar in 2004. Just for comparison, Central Park in New York extends for a mere 2.5 miles. That was the Pororoca wave, and it can only be surfed for 3 days a year. It's pretty powerful, so it sort of pushes you. But there are definitely some tough spots where it's not that easy to catch waves. If you're looking for the gnarliest surf spot, Pipeline in Hawaii is where it's at. But beware, it's not for the faint of heart. This place is known for its massive waves that can reach up to 20 feet tall. And did we mention the shallow reef? Yeah, wipeouts here can result in some serious injuries, or worse, you might end up sleeping with a fish. The waves at Pipeline are also super unpredictable, so you never know what you're going to get. It's like a box of chocolates, except instead of chocolate, it's huge waves that could crush you like a bug. But hey, if you're feeling brave, the annual Billabong Pipe Masters competition is held there every winter. Just make sure to bring your A game and a change of underwear. Even the most experienced surfers approach Pipeline with caution and respect. It's like trying to tame a wild animal. One wrong move and you're toast, or dinner. So if you're ready to ride the gnarliest waves in the world, come on down to Pipeline. Just don't say we didn't warn you. For those who are dreaming California, there's a tough spot in the Golden State for you. Mavericks is notorious for its massive swells and strong currents, making it a challenge even for experienced surfers. Hold on tight, because this wave is gonna take you for a ride. First off, let's get one thing straight. Mavericks ain't for the weak. This bad boy can reach heights of up to 60 feet. But hey, if you're a seasoned surfer and you're feeling brave, then Mavericks is the place to be. Located just off the coast of Half Moon Bay, this spot is known for its massive swells and killer waves. It's like the Hulk of surf spots, big, bold, and ready to smash. Now, don't go thinking that Mavericks is all about the waves. Oh no, my friend. This spot is also home to some of the coolest surfers around. These dudes and dudettes live for the rush of catching a maverick wave, and they'll do whatever it takes to get out there. But here's the thing, Mavericks isn't just about surfing. It's also about community. These surfers have each other's backs, and they know that when they're out there on those massive waves, they're all in it together. It's like a big, salty family. So there you have it, folks, Mavericks, the wildest, most insane surf spot in California. If you're up for the challenge, grab your board and head on out. Just remember, when you're staring down a 60-foot wall of water, it's okay to scream like a little girl. We won't judge. Chupo in Tahiti also has some of the heaviest waves in the world, breaking over a shallow reef and creating intense barrel rides. First of all, the name itself is a mouthful. It's pronounced Chupo, and it means broken skulls in Tahitian. Yeah, you heard that right, broken skulls. The waves at Chupo are massive and can reach up to 23 feet high and break over a shallow reef, which creates a super powerful wave that can barrel for hundreds of yards. And if you wipe out, well, let's just say you'll be getting up close and personal with that reef. It's like a cheese grater for your skin. So make sure you bring some Band-Aids and a good insurance policy. But hey, if you're up for the challenge, Chupo is one of the most epic surf spots in the world. However, I hope you're going to choose a much safer spot. If you're looking for some cool waves but don't want to risk your life, then you got to check out these safe surfing spots around the world. First up, we got Waikiki Beach in Hawaii. This spot is perfect for beginners and pros alike, with consistent waves and a sandy bottom. Plus, there are lifeguards on duty to keep an eye out for any trouble. Next, there's Bondi Beach in Australia. This iconic beach is known for its beautiful scenery and chill vibes, but it also has some great waves for surfing. The water is shallow, and there are plenty of surf schools around to teach you the ropes, or in this case, the boards. But if you're looking for something a little more exotic, head over to Nocera in Costa Rica. This spot has warm water, consistent waves, and a laid-back atmosphere. Plus, the locals are super friendly and will welcome you with open arms. Last but not least, there's Muizenberg Beach in South Africa. This spot has some of the most consistent waves in the world, but they're not too big or dangerous. Plus, there are shark spotters on duty to keep you safe from any unwanted attention from local carnivores. But no matter how safe the spot is, you're still going to need some cool life hacks to bring your surfing to a brand new level. Have you ever wondered why surfers use wax on their boards? Well, let me tell you, it's not just for show. See, when you're out there shredding the gnar, you don't want to slip and slide all over the place like a penguin on ice. That's where the wax comes in. Basically, the wax creates a grip on the board so you can stick to it like peanut butter on bread. Without it, but here's the thing, not all wax is created equal. You gotta find the right kind for your board and the water conditions. It's like choosing the right flavor of ice cream for your cone. You don't want to end up with mint chocolate chip when you really wanted Rocky Road. So, next time you see a surfer waxing up their board, just remember they're not doing it for the smell, although some waxes do smell pretty sweet. They're doing it so they don't wipe out and embarrass themselves in front of all the folks on the beach. And that's worth its weight in gold. And by the way, did you know that rubbing a little bit of wax on the bottom of your feet can give you a better grip on your board? Yeah, it's like magic. No more slipping and sliding around like a seal on a wet rock. Another common hack is to wear earplugs. You see, there's even a condition called surfer's ear. Surfers are constantly exposed to cold wind and water, and some of them even surf in cold temperatures. If your ears are constantly exposed to cold, your ear canal may shrivel up. As a consequence, water, wax, you, and even air all get trapped in your ear, which may lead to certain infections. So, to prevent water and cold air from getting trapped in their ears, pro surfers like to use earplugs. But even if you're just a newbie, you gotta use their tip. Oh, and here's another classic. If you're surfing in cold water and don't have a wetsuit hood, just rub some petroleum jelly on your ears to keep them warm. Hey, why do you think some surfers have clear nail polish on their emergency kits? It's not for their nails, but for their boards. So, if you're dealing with a stubborn ding in your board, grab some clear nail polish and fill in the crack. It'll keep water from seeping in and causing more damage. However, pros will say that nail polish is a terrible idea, and there are a lot of repair kits out there. Yeah, this one's up to you. So, there you have it, my fellow wave riders. Now go out there and shred those gnarly waves like the pro you are.
Your kitchen sink is filled with dirty water. You've just washed the dishes, and you pull the plug out of the drain hole. Do you see how the water forms a funnel, and all the pieces of food get into its center? This is a small whirlpool. Now imagine that this is not a kitchen sink, but a sea with a several feet wide whirlpool. And it draws in not pieces of food, but a small boat. And you're on this boat. You jump off the side and try to swim away, but the whirlpool is stronger than you. It attracts you despite your attempts to swim away. So the first thing you should do is calm down. Yeah, it isn't easy when the deep sea is trying to swallow you up, but if you don't save your strength, you won't be able to survive. And now remember one life hack. Do not try to swim in the opposite direction when the current from the shore carries you away. Head to the side. Thus, you escape from the stream sooner or later and can safely swim to the beach. Inside the whirlpool, you have to act similarly. You need to stop struggle and swim in the direction of the flow. Thus, you'll keep your energy and increase your speed. But don't swim at the very center of the vortex. Try to move away from it in the last moment and you'll get out. Now go to the surface and stay away from the whirlpool. Great! You have survived. You promise yourself never to go to sea again without a life jacket. But of course, the best way to escape from the whirlpool is not to get caught. If you're going on a sea cruise or kayaking at the mouth of the river, find out all about these places. Perhaps they are filled with water traps. You swim to the shore and decide to learn all about whirlpools. It forms in the sink or bathtub because the water begins to drain into the hole and swirl. There are no drain holes in the sea, lake, river, or ocean, and water is formed there because of the collision of two currents. A strong wind can only create one current. The difference in water temperature and its density can make another. Also, the current can be caused by tides. This is when the moon's gravity affects the water. So when two currents flowing in different directions meet, they form a vortex. Two streams of water swirl around each other and move down in a spiral, creating an empty space in the center. Most of the whirlpools are too small and don't pose a danger. But if the water vortex is strong and large, it can sink ships. Such strong whirlpools are called maelstroms. They are usually formed when two currents collide near narrow reservoirs and straits. The world's largest and most dangerous maelstrom is located in the Saltstraumen Strait in northern Norway. Every 6 hours, a whirlpool forms there with a diameter of about 33 feet wide and 16 feet deep. And it can be several whirlpools formed at once. Ships sailing through the bay follow a strict schedule to avoid falling into the water trap. This whirlpool got into the Guinness Book of Records as the largest in the world. However, some whirlpools are hundreds of times bigger, but they are invisible. Giant whirlpools in the Arctic Ocean can reach 18 miles in length. This is the size of a city, and these giant whirlpools are invisible. Fortunately, they are not as dangerous as those that form in Norway. The waters of the Arctic and Atlantic Oceans mix and form water vortexes invisible to satellites. Usually scientists notice such whirlpools with the help of thermal imagers or a change in the color of the water. When the current filled with marine life mixes with lifeless waters, it is visible from the satellite. But the new giant whirlpools are masked under a layer of water with the same temperature. They hide deep enough not to be noticed by satellite thermal imagers. Scientists managed to catch them using gliders. These small pilotless submarines float underwater and record information about the temperature and salt level. Scientists discovered that these whirlpools formed because of the collision of cold and warm currents. Warm water here is rich in nutrients, while cold water is almost lifeless. In this way, warm currents share useful elements and spread them evenly throughout this region of the ocean. Observing invisible whirlpools can help scientists uncover many details about the structure of ocean ecosystems. Whirlpools exist not only in water but also in space. Vortexes from the plasma energy of the sun can be several times wider than the radius of our planet. However, all this solar radiation cannot create giant vortexes on Earth because the magnetic field protects us. The solar wind glides past the planet's atmosphere like a wind over the ocean's surface. But a little energy still manages to break through the protection. Solar whirlpools insert an electrified gas into the magnetic field, creating holes through which the sun's plasma passes through the atmosphere. If whirlpools happen during the collision of different currents, it means that you can predict their appearance in advance. But there are unpredictable natural phenomena in the seas and oceans that pose a danger for small boats, yachts, giant ships, and oil rigs. The phenomenon is called a rogue wave. So now let's get aboard your yacht and sail somewhere in the ocean. It doesn't matter what ocean and where exactly you are, because rogue waves can appear anywhere. A small storm is starting, but your boat can easily handle it. The wind raises small waves that beat against the hull of your yacht. But then, among these waves, one giant appears several times larger than all the others. It would quickly turn your vessel over like a paper ship. But fortunately, this wave passes by and dissolves into the sea. This unpredictable wave of enormous power can destroy huge ships in a second, and such disasters have happened many times. Sailors all over the world told each other stories about the giant waves that appear during a storm and in a quiet sea. Many considered such waves only fairy tales, such as legends about the Kraken and Atlantis. But at the end of the 20th century, people were able to capture this sea phenomenon with a laser detector that measured the size of the wave. On January 1st, 1995, a massive rogue wave crashed into an oil station in the Norwegian North Sea. There was a storm that day, with big waves about 40 feet long. At some point, they formed a big guy, an 85-foot wave. That day, rogue waves turned from a fairy tale into reality. Researchers estimated that this natural phenomenon may destroyed about 22 supercarriers only in the second half of the 20th century. Also, scientists discovered that just 1 in 10,000 waves is a rogue one, and every year, their height increases by 1%. Some of the largest rogue waves reached a height of 100 feet. It's like a 10-story building. This giant can easily break even the strongest and largest ship. Scientists can't always predict their appearance, and still don't know their nature, so rogue waves make the ocean a much more dangerous place than we thought. According to one version, rogue waves appear because strong winds create big waves. When two such waves collide with each other, a giant rogue wave may appear. Another theory says that eddies create rogue waves. These eddies form along the edges of the ocean currents, and then they drift separately for a long time, increasing kinetic energy and forming eddies field. The kinetic energy contained in these fields can charge the waves and increase their strength. However, scientists study microwaves and light to understand this phenomenon better. It turned out that these sea waves are similar in their behavior to these two natural things. The researchers hope studying light waves will help understand the nature of rogue waves.
Planet Earth is full of wondrous phenomena. I mean, can you imagine going for a midnight swim and suddenly finding yourself surrounded by a glowing blue haze? As if there were huge pillars of light coming out of the seabed directly toward the surface. This experience is rare, but it sure is magical. This chemical reaction is known as bioluminescence, and it can happen in different situations. One example is when tiny algae organisms migrate closer to the seashore. When these algae are disturbed, they try to defend themselves by glowing, and just happens to create the most beautiful spectacle. There's another place in the world where you can see a similar thing, but it's caused by a different creature. This place is in New Zealand. Hidden deep within the country's caves live glowworms. They're the larvae of medium-sized narrow beetles that happen to be luminescent. If you're lucky enough to tour these caves, you'll feel like floating inside an underground galaxy. Recently, a video of a super rare phenomenon started circulating on the web. Take a quick look at it and see if you can make out what it is. Okay, it looks like a river, right? But it doesn't look as if any water is flowing there. When the Iraqis first saw this happening, they didn't know what it was, so they just called it the Sand River. It sure was a good guess, but a flowing river of sand would be something too out of this world to be true. It turns out that what these people saw was more or less an optical illusion. It's not sand, but it's not exactly water either. Here's what happened. In arid environments, it's not so uncommon for hail to fall. And in the case of Sand River, what we actually see is thousands and thousands of floating hailstones. Oh, and if you don't know what hail is, it's frozen rain that pours down in the form of small pebbles of ice. That would be something to see. Say you're driving through the countryside and suddenly spot a mushroom-shaped cloud. Uh-oh. Or maybe it's a spaceship of another civilization. You don't quite know what it is, but you do realize that it's huge. Should you continue driving toward it, or should you turn around and drive in the other direction? Well, you should know that a cloud like this indicates a huge thunderstorm is happening inside. And not just a storm, but a mesocyclone. A mesocyclone is a rotating updraft that can span several miles. It's usually accompanied by torrential rains and strong winds. So, if I were you, I'd turn that car around and head in the opposite direction. Whew. You know Thor? I guess he might live inside this next natural phenomenon. Sometimes, when a volcano erupts, this process can be accompanied by huge thunderbolts. Scientists often refer to it as volcanic lightning. They're still debating why this thing occurs. One of their guesses is that when a volcano erupts, it projects positively charged debris into the atmosphere. These charges then react with the already present negative charges, which can produce a bolt of lightning. Cool, huh? The first time anyone witnessed something like this was during the eruption of Mount Vesuvius in 79 CE. Nah, it wasn't me. But here I am wondering, were there or were there not any sightings of Thor? Hey, sometimes when I work out too much, I get Thor. Now, all the way down in Senegal, Africa, we'll witness another unbelievable sight. Some 18 miles north of Dakar, the country's capital, there is a unique lake. Arriving there, you might imagine you're walking out of a spaceship and stepping on an unknown planet. After all, have you ever seen real-life pink water before? Lake Retba, or Lac Rose, as the locals call it, has become internationally famous for being vivid pink. And yes, you can swim there if you'd like to. But you should know that the water there is extremely salty. Lake Retba is known to be one of the world's saltiest lakes, with a saline level of over 40%. And in case you're wondering why the water is pink, I assure you this has nothing to do with otherworldly factors. It's actually due to high levels of salt. The algae, Dunaliella salina, is responsible for the pink hue. These algae produce the red pigment that absorbs sunlight, giving the lake its striking pink color. But if you'd like to see the lake at its brightest, you should go there during the dry season, between November and June. During other months, rainwater dilutes the pigment, and the color of the lake becomes less distinct. Lake Retba has turned into a famous international attraction recently because who wouldn't love a picture of them swimming in the pink water? You might have heard of the Aurora Borealis, aka the Northern Lights. This phenomenon has continued to mesmerize scientists and tourists alike ever since it was witnessed for the first time. Now to see it, you have to be pretty lucky. You'll need to travel to the extreme north or south points of our planet. And even then, you'll have to hunt this phenomenon down and hope the sky will put on a show for you. The Aurora Borealis is an extremely rare phenomenon, and although these greenish lights look delicate, they're actually the fruit of a rather rough event. This spectacular light show occurs when energized particles from the sun slam into Earth's upper atmosphere. But it sure is a sight to behold, isn't it? Can you imagine a hill that never stops burning? Located in the Arctic region of Canada, the so-called Smoking Hills are an unmatched sight on our planet. And here, things get a little science fiction-y, since some of the minerals found in these hills have only been discovered outside Earth, on the surface of Mars. The ground of the Smoking Hills has been releasing smoke for at least a couple hundred years, non-stop. Explorers thought the area was home to an active volcano, but that wasn't the case. As science explains, the soil in the area is formed by sulfur and coal, and when these elements get in contact with oxygen, they spontaneously ignite, releasing constant smoke. I just want to warn you, don't get any touristy ideas. The environment is extremely hostile to people. The smoke is toxic, and its temperatures are dangerously high. So let's move on before smoke gets in our eyes. Hey, there's a song there. Have you ever heard of something called a natural snowball? This can be proof that nature is really perfect. In 2016, the beaches of the Gulf of Aab, a bay in the Arctic Ocean, filled up with rows and rows of giant snowballs. Think balls measuring up to 3 feet across. This is a rare yet beautiful phenomenon that happens when smaller pieces of ice end up getting rolled by strong winds and water. The further they roll, the more ice they gather and the more polished this ice becomes. Such snowballs end up as giant, perfectly shaped spheres. They look pretty amazing on their own, but hundreds of them together? Wow, think of it. You could have a snowball fight between giants. There are also some snowballs that turn into huge rolling donuts. This shape occurs only in perfect temperature conditions when the snow is both hard and fluffy. A snowball begins rolling down, gathering more and more snow until, suddenly, its middle part collapses. This way, the snowball acquires its donut shape. Does it also taste as good as a donut? No. Now, let's say you go for a hike, but instead of blue skies, you see a huge cloud of fog. Now, this may ruin your photo ops, but there's one thing you can hope for. Foggy days are perfect for a phenomenon known as the fog bow. Its other name is the white rainbow. It occurs because of the tiny size of water droplets that form the fog. They're even smaller than 2/1000ths of an inch. You know, teeny tiny. So instead of a multicolored rainbow, you get a transparent one with red outer edges and a bluish inner border. Cool. In November 2020, a wave the height of a 4-story building was recorded off the coast of Vancouver Island, Canada. The team at Marine Labs, the company that operates the buoy that got caught in it, couldn't believe the data they saw. Everything was normal, then, unexpectedly, a vast force came, pulled the buoy down, and then sent it up to a peak before taking it even deeper. The probability for such a huge wave to form is once in 1,300 years, so they had to be sure it wasn't a technical mistake. Marine Labs sent the data to a rogue wave scientist at the University of Vancouver. They analyzed and validated the findings and shared them in February 2022. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Luckily, this giant didn't leave any damage, as it happened too far offshore. For centuries, rogue waves were believed to be real only in the stories of sailors. Christopher Columbus himself mentioned a rogue wave, but back then, it wasn't officially a thing. In August 1498, he was on his 3rd expedition to the Americas. As they were passing through a strait near Trinidad, a huge wave lifted the boats. They managed to survive and continue the journey, and the area is still known as the Mouths of the Dragon, named this way by Columbus. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got caught in a terrible storm and witnessed several waves over 80 feet tall. One of them was the height of a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and spread the story of the gigantic waves. But back then, scientists were sure waves couldn't be taller than 30 feet. So everyone took this story as a tale. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This sea monster of the North Sea hit the Norwegian gas platform Draupner on New Year's Day. It reached a height of 84 feet. The waves surrounding it were twice as small. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. It became a sensation in the scientific world because it wasn't like any other type of wave they'd studied before. So they gave rogue waves an official definition. It's a wave more than twice as tall as others around it. These bad boys, also known as freak waves, monster waves, and episodic waves, can pop up lightning fast in a stormy sea or show up out of nowhere in calm waters. They have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters just trying to do their job. Rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. Scientists and sailors singled out some statistics. Rogue waves more often form when wave trains run into fast ocean currents. The coast of South Africa is one good place for that. There are concerns that these water beasts may happen more often in the future because there's more energy in the atmosphere and ocean. It means larger and more frequent rogue waves and more ships lost at sea. Rogue waves aren't limited to oceans and can even occur in lakes. Lake Superior witnesses something that got the name Three Sisters. It's a series of three large waves, one after another. The second wave covers the ship decks before the first one is gone. The third wave jumps in and adds extra water. These three sisters overload the ship. There's a theory that this phenomenon took down the steamship Edmund Fitzgerald in 1975. Rogue waves are also dangerous because they form rogue holes in the water. When the wave builds up, it draws in all the water around it. So, near the base, these holes can be very deep. If the bow or stern of a ship ends up in one, the ship can instantly sink. Some oceanographers believe that rogue waves are to blame for the disappearance of ships in the notorious Bermuda Triangle in the Atlantic Ocean. Storms from several directions converge in this mysterious area, so rogue waves are more likely to gain force here. And because they can reach a height of 100 feet, they can theoretically bring down an airplane, not just ships. There are two main theories trying to make sense of how rogue waves happen. First up, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. Now, when these waves cross paths, they team up and become stronger, cooking up a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they share some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and toss it into a fancy math model that paints a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but as scientists measure more rogue waves, mathematicians may find a way to alert us of the upcoming rogue waves rising out of the water. Sometimes you can hear the term sneaker wave as a synonym for rogue waves, but oceanographers claim there's a difference. Rogue waves occur mostly in the ocean, and sneaker waves build up at the shore. They're also known as king waves and sleeper waves, and they roll up much faster than usual waves when they approach the beach. They always appear without warning after smaller waves and can be powerful. They can carry swimmers further away into the ocean. But the worst part is, they can also sweep you off your feet and into the water when you're casually strolling on a jetty or the beach, or on an outcropping nearby. Oregon State University researchers found that sneaker waves form in offshore storms that carry wind energy to the ocean surface. With all that energy, several waves unite and overlap into one beast that stands higher and goes further ashore than a regular wave. Another thing that makes them more dangerous is that, just like rogue waves, they're hard to predict. Fishers, surfers, and others who spend a lot of time by the water normally know when and what to escape when it comes to big waves. With sneaker waves, that logic doesn't work. There is no set time of the year when they're more active either. But putting together some data shows you're more likely to experience one of those somewhere between April and October, and the peak would be in October and November. Sneaker waves carry huge amounts of water, sand, and gravel. Those can fill up your shoes in a matter of seconds and sweep you off your feet if you're unlucky enough to be ashore at that moment. These sea monsters also have the power to move huge logs, which carries another hazard.
Are you a pro swimmer, brave enough to take a dip in any ocean or sea? Bad news. There are some places you should avoid no matter how well you swim or dive. Some of these places have dangerous underwater rocks, strong currents and tides. Others are famous for legends about monsters and mysterious creatures. So let's dive into this aquatic horror show. Have you ever heard the word the strid? It's a variation of the word the stride that is used in Yorkshire. And it refers to a narrow section of the river wharf that's so small you could jump over it. But don't be fooled by its size, it's one of the most dangerous spots around. Even taking a step into the water can have dire consequences. The river wharf has a forceful current, and since the strid is so narrow, it's even stronger in that area. The intense water flow has eroded the limestone around the strid, which created hollow spaces much deeper than the rest of the riverbed. Here's the secret. The current has also weakened the banks of the strid from below. So, the ground you're standing on, admiring the rapid flow, is probably just a fragile ledge hanging over treacherous waters. There's no record of anyone who found themselves in the water of the strid and found their way out of it. And the worst part? You wouldn't even guess that this innocent-looking stream could be such a danger. So, my advice to you, my friend, is to stick to a safer body of water for your aquatic adventures. If you're looking for a weekend getaway in California, Horseshoe Lake is the spot for you. It's got everything. Sandy beaches, hiking trails, and picnic areas, but wait, there's more to it than meets the eye. This lake has a dark side, namely around 100 acres of dead trees that surround it. And it's not just the trees that have been claimed by this lake. The earthquakes that hit in 1989 and 1990 unleashed carbon dioxide from under the hot magma. The gas seeped out into the air, damaging all the life around the lake. Even now, Horseshoe Lake is just as dangerous as it was 30 years ago. What makes it so scary is that the levels of this toxic gas change randomly. Warning signs that are posted everywhere certainly could give a horror film touch to a fun hike in the woods. In Kauai, Hawaii, there's a group of stunning waterfalls that used to be a popular destination for tourists. Kipu Falls, as they're called, were once the go-to spot for swimming and diving. To get to them, you had to take a long walk along a dirt path until you finally arrived at a breathtaking view of a 20-foot waterfall pouring into a crystal-clear pool below. But since 2011, this area has been off-limits to the public. Why, you ask? Well, there have been a lot of accidents at Kipu Falls. Obviously, jumping off the top of the waterfall would be an obvious reason for that, but in addition, there were much more mysterious cases. Witnesses tell tales of swimmers peacefully enjoying the pool at the bottom of the falls, only to be suddenly dragged under the surface. No definite explanation was found to these accidents. The locals believe that the water spirit Mo'o is to blame because it doesn't appreciate being disturbed by loud tourists. There's also a theory of a powerful whirlpool at the bottom of the pool. In any case, guide publishers do not mention Kipu Falls anymore, and trespassing is severely punished. The Samisen Hole, located in the Gulf of Thailand, is the ultimate spot for thrill-seeking divers, but it's also the most dangerous one. With a drop of 280 feet, it's the deepest diving site in the region. But its depth is not the only reason it is considered a place to avoid. The area is a major shipping zone for giant oil tankers. The strong currents around the hole make diving even more treacherous. And if that's not enough, the Tsunamis hole is also home to deadly barracudas that could easily attack unsuspecting divers. The water is so murky that visibility is nearly zero, making it challenging to spot these aggressive sea creatures. All in all, the Tsunamis hole is a breathtaking but extremely hazardous spot that should only be explored by experienced divers with nerves of steel. Let me tell you about New Smyrna Beach, the shark attack capital of the world. If you're looking for a relaxing vacation spot in Volusia County, Florida, you may want to reconsider this beach. The waters around New Smyrna Beach are teeming with fish, which attracts a lot of sharks. In fact, there have been so many shark attacks reported in this area that it's earned the title of the shark attack capital of the world. Even scientists have warned that if you go for a swim there, you're bound to get up close and personal with at least one of these creatures. We are talking about a distance of 10 feet, and in many cases you wouldn't even notice it. To make matters worse, the bull shark, one of the most dangerous and aggressive types of sharks, has been spotted in these waters. Once again, Kauai is on our list. The beach on Nepali coast called Hanakapiai Beach might look like heaven on earth, but don't be fooled. To get there, you have to trek through a super steep, rocky 2-mile trail. There are no lifeguards on this remote beach, so even if you decide to take a dip in the water, you're on your own. The biggest threat to your safety is the incredibly strong rip currents. They are almost always present because there are no reefs to shield the shore. And if someone gets caught in one, there's no safe place to swim to for miles. The nearest safe beach is 6 miles away. Trust me, this beach doesn't have the best track record in terms of safety, so it's highly advised that you stay out of the water if you end up at this beach. Let me tell you about a place that looks like it's straight out of a horror movie. We're talking about Berkeley Pit, which is an artificial lake situated in Butte, Montana. The first thing you'll notice about this place is that it has an eerie blood-red color that can only be described as unsettling. You might be tempted to take a dip, but that would be a grave mistake. Don't even touch it. The water is extremely dangerous due to the heavy metals present in it, such as cadmium, arsenic, zinc, lead, and copper. They come from the rocks that surround the lake and make the water super acidic. In fact, this place used to be an open-pit copper mine, hence its color. So if you want my advice, avoid this place like the plague. There are 3 lakes in Africa that maybe are the most dangerous places of all that I have mentioned so far. They're all located in Africa. Lake Monoun and Lake Nyos in Cameroon and Lake Kivu in Rwanda are all like ticking timers ready to go off. They were formed over underground pools of molten rock, and sometimes this molten rock releases toxic gases like methane and carbon dioxide right into the water. When this happens, the gases can build up until they suddenly burst out of the water, creating massive waves that can wipe out everything in their path. This type of outburst is called a limnic eruption, and it can release a cloud of poisonous gas that can be harmful to everything in the vicinity. The most terrifying part? These explosions can happen at any moment with no warning. So if you ever find yourself near one of these lakes, you'd better be on high alert, because you never know when the next accident might happen. Maybe you know other places you wouldn't recommend for a fun swim? Share your anti-recommendations in the comments below.
Hey, don't freak out. Those red waters you see aren't blood oceans. It's just a natural occurrence called the red tide. Red tides often happen in Florida, especially in the West Florida shelf, and they can stick around for weeks or even months. They're basically caused by an increase in algae levels, hence the color. Those algae produce toxins that can be harmful to marine life. They can also be bad news for us humans, causing symptoms like upset stomach and urgent bathroom trips, if you're picking up what I'm putting down. Volcanoes are super scary, but there's nothing scarier than getting taken out by a pyroclastic flow. These fiery flows move crazy fast and reach insane temperatures, like hotter than your oven on a pizza night. They're like a fireworks show of volcanic eruptions filled with ash, lava, and hot gas, speeding down mountains at 50 miles per hour. Some researchers claim they might even hit speeds of 450 miles per hour, almost as fast as a passenger jet. If you're unlucky enough to be in the path of a flow, you're in big trouble. The heat alone can turn you into a human barbecue, even if you try to hide in a building. The air around the flow can reach temperatures high enough to fry your insides, burn your clothes off, and leave metal melted into your skin, which almost sounds like a Marvel origin story. However, a lot of people have met their end because of these flows. But there's one crazy story about a guy named Luger Silbaris, still sounding like an origin story. So on the 7th of May, 1902, there was a major eruption on the island of Martinique. The night before, Silbaris had gotten into trouble and ended up in jail. Maybe this is a villain origin story. He'd been locked in a sturdy cell facing away from the volcano. The next morning, Mount Pella unexpectedly erupted, destroying St. Pierre within minutes. The flows wiped out around 30,000 people, but Silbaris survived in his cell and became known as the guy who lived through doomsday. The rescue team found him 4 days later. By the way, the cell still stands today. I hope somebody tested him for superpowers. Back on August 21st, 1986, a guy stumbled upon some animals showing no signs of life on his way to Nios village in Cameroon. To his shock, he later found out that everyone in the village had mysteriously passed away. The same thing happened at Lake Manaun in 1984. Turns out, those tragic incidents were caused by something called Limnic eruptions, which are pretty rare disasters where carbon dioxide suddenly bursts out of lake waters, creating a hazardous gas cloud. These type of eruptions usually happen in lakes with high levels of CO2, which can be caused by things like volcanic gases and high pressure. Any little change in temperature or pressure can set off an eruption. So, experts have started looking into ways to safely release CO2 from lakes like Manaun and Nios in order to lower the risk of more disasters in the future. In March 2024, a video captured a terrifying moment of a woman disappearing into a sinkhole while browsing through a Chinese department store. Guess she got more than she bargained for. Ha 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 ha. Moving on. The scene unfolded as the floor beneath her gave way, sending her plummeting into the abyss. In the midst of the chaos, another customer frantically ran away before returning to check on the woman who had fallen. Their quick thinking and the swift response of emergency crews and firefighters saved the day, resulting in only minor injuries for both women. I'm glad that lady checked on her because I would be gone. An Anvil cloud is basically a big cloud made of ice particles that forms at the top of really tall thunderstorms, or those huge cumulonimbus clouds. The flat top shape is caused by the air rising in the storm and spreading out when it hits the stratosphere. That's why it's called an anvil. It looks like the tool metalworkers use. Duh. The air from the Anvil cloud is cooler than the stratosphere air, which keeps it from going any higher. You can spot Anvil clouds from really far away, sometimes over 100 miles. Often you might see streaks of snow coming from the edge of the cloud known as virga. The snow disappears before hitting the ground because of the dry air. If you notice clouds poking through the flat top or bubbling up, it's an overshooting top, a sign of a super strong storm. Anvils are known for producing dangerous lightning. Normally, lightning comes from the bottom of a storm, but anvil clouds can produce really powerful lightning from the top. This lightning can strike out of nowhere, even from up to 30 miles away. So keep an eye on those anvil clouds if you see one forming nearby. Lahars are no joke. They're basically fast-moving, super dangerous streams of rock, ash, and water that come down the slopes of volcanoes. It's important for everyone to be aware of them. Scientists, policymakers, and even us regular folks. By understanding how lahars work and their potential impact, we can try to stay safe when volcanoes start acting up. Saving lives during natural disasters is the name of the game. There are two main types of lahars: debris lahars and mudflow lahars. Debris lahars are full of solid stuff like rocks and ash, while mudflow lahars are more waterlogged and sludgy. Lahars can be triggered by the rapid melting of snow or ice, heavy rain falling on loose volcanic material, or even a crater-like eruption. The volcano's characteristics and presence of water are key factors in how lahars form and move downhill. When lahars come barreling down mountains at speeds of up to 120 miles per hour, carrying loads of debris, it's a recipe for disaster. Unless you have a surfboard, but I doubt you'll have a surfboard on a volcano. Just saying. Also, it won't work. Going to the beach for a sunny vacation is the best. There's nothing like basking in the sun, feeling sand between your toes, and hearing waves crash against the shore. But even though it's all relaxing and picture perfect, always keep an eye on the water and never turn your back on the ocean. You may know about rip currents and tides, but have you ever heard of square waves? It's a real thing, and it can be pretty scary. Square waves, also known as cross seas, happen when two swells meet, forming a unique square pattern that looks like a checkerboard. They can be found along coastal areas, and while they are rare, they can create waves up to 10 feet high and make it tough for boats and swimmers to maneuver. If you find yourself in the water with square waves, you might feel like you're fighting against two different currents. The best thing to do is to not go too far out to begin with, and get out of the water as soon as the waves become too strong. Square waves are more dangerous for boats and ships, so it's best to stick to the shallow waters and stay safe. Whirlpools and maelstroms are powerful natural forces that have scared sailors for years. They happen when certain weather and current conditions come together just right. Most of them are safe if you stay away, but let's see what they really are and how they form. A whirlpool is basically water that starts spinning when two currents meet, or one current hits something solid like a wall. They can be big or small, depending on the speed of the water and waves. Most aren't dangerous, but there are also maelstroms, which are large, forceful, and violent whirlpools, caused by ocean tides and narrow straits. Tidal currents in places like Norway's Saltstraumen and Maelstromen can create massive whirlpools. Scotland's Corribrecken whirlpool is one of the world's largest. Other examples of whirlpools can be found in Japan, Canada, and New Zealand. Are they portals? They're definitely not portals. Researchers have recently looked into ancient underwater volcanic eruptions and how they affected Earth's climate. They studied materials from Bronze Age eruptions to learn more about their scale, dangers, and impact on climate. For example, one eruption about 3,600 years ago in the Aegean Sea caused chaos in Santorini. The study focused on this event to understand its importance. By analyzing volcanic deposits, the researchers gained insights into how future eruptions could affect climate. They discovered that sediment waves from shallow underwater eruptions could lead to tsunamis and impact the ocean floor. These findings help us understand how underwater volcanic eruptions relate to the marine environment, which can help us predict climate changes in the future.
The sea is kind of rough today. Nothing special, but still, you have that sinking feeling in your stomach. Call it a sense of foreboding. Something bad is going to happen, and then you hear terrified shouts. You turn around and see a giant wave, much higher than the one surrounding it. Is it a tsunami? That's true. When people think of frightening, destructive waves, tsunamis are the first thing to come to mind. But the one that is going to crash against your ship has a different nature. It's a rogue wave. Both tsunamis and rogue waves can lead to catastrophic consequences, but the difference lies in what causes these walls of water and where the destruction they bring about occurs. So, imagine a giant 60-foot-tall wave rolling over your ship. It's a miracle that the vessel doesn't sink. This massive wave, a rogue wave, seems to have appeared out of the blue, very suddenly and unexpectedly. But however mysterious, solitary, and ominous rogue waves may seem, they're actually not that rare. Now, imagine the average room in your house. The ceiling there is likely 8 feet high. A typical two-story house is somewhere between 20 and 30 feet high. And the Statue of Liberty is 111 feet tall if we measure it from the toes to the top of the head. Now you have something to compare rogue waves with. The largest of such waves can reach a height of 50 to 90 feet. To be considered rogue, a wave must appear seemingly out of nowhere and be higher than other waves in the area. But how much higher is still under debate. Some experts think it should be at least twice as high as other large waves in the area, while others disagree. Rogue waves are also steeper than regular waves, which normally take the form of massive swells. This allows ships to maneuver up and down such waves, even when they're really high. A rogue wave, however, looks like a wall of water, and since it's steeper than other waves, it slams into a ship with enormous force, sometimes breaking over the vessel. Another reason why rogue waves are a mystery is that no one has ever filmed the formation of such a wave and followed its life cycle. There are several photos of rogue waves, but for many centuries, the only evidence of their existence was legends and stories told by sailors who survived them. Scientists are still not sure how rogue waves form, but one theory involves wave reinforcement. It happens when two waves interact and their heights get combined. So when a 15-foot wave passes over a 30-foot one, let's do the math. It results in a short-living 45-foot wave. But rogue waves can occur not only in the ocean. On November 10, 1975, on Lake Superior, a group of 3 rogue waves, also known as the Three Sisters, might have sunk the SS Edmund Fitzgerald, an American Great Lakes freighter. The ship and the crew members were lost in the catastrophe. The waves followed each other too closely, so the ship couldn't recover and shed the water from the first wave before the following one struck. The captain of a ship that was not far from the Fitzgerald reported that his vessel had been hit by 2 30 to 35-foot waves. These waves, likely followed by a third one, then moved further in the direction of the Fitzgerald and might have caused the sinking. Now, let's wave bye-bye to that, and let's move on to tsunamis. It is an extremely dangerous natural disaster. It's very different from rogue waves. In most cases, a tsunami is caused by an underwater earthquake. Usually, when a tsunami is born, it's just a few feet high. But the closer it gets to the shore, the larger it grows. Soon it enters shallow waters and starts to slow down. The first tsunami wave crashes against the shore. Its top moves faster than the bottom, and that's what makes the wave so high and steep. The lowest point of the wave gets to dry land first. In the process, it creates a vacuum effect that pulls the water away from the coast, burying the harbor and seafloor. Those who recognize this first sign of an approaching tsunami still have a chance to save their lives. 5 minutes later, an enormous wall of water hits the shore and wipes out everything in its way. But it's not just a single wave, there are many. This phenomenon is called a wave train. How fast this train is traveling depends not on how far it is from the source of the waves, but on the ocean depth. Tsunamis can move as fast as a jet plane in the middle of the ocean, but once they enter shallow waters, their speed drops. The first tsunami wave isn't usually the strongest, but lots of people don't know it and make the grave mistake that sometimes costs them their lives. After the first wave is gone, they relax and believe the danger is over. That's why the next waves, much bigger and more powerful, catch them off guard. Now sometimes a tsunami comes as a torrent of foaming water. At other times, it makes the sea withdraw, leaving behind stranded fish and overturned boats. Also, if you spot a slight rise in sea level, it might be the sign of an approaching tsunami. The incoming water is the first tsunami wave. The second one can be even larger, and it comes sometime later. You can also notice seawater bubbling, swirling, and creating bizarre patterns. It's another sure sign a tsunami is near. Repeated wave surges can also warn you about a tsunami. If you see unusual swells coming at regular intervals, it might be time to evacuate to high ground. Surprisingly, some of the largest tsunami waves in the world were caused by landslides. For example, a landslide in Lituya Bay in Alaska formed a megawave, one of the largest ever recorded. Its height was 1,720 feet. The mega tsunami surged over the headland, washing away trees, plants, and soil down to bedrock. The wave reached more than half the height of the Burj Khalifa, the tallest construction in the world. When a third of the East Molokai volcano in Hawaii caved in and collapsed into the Pacific Ocean, it triggered a tsunami the size of one of the tallest buildings in the world, Shanghai Tower. The wave was around 2,000 feet high. Another bizarre and dangerous ocean phenomenon is square waves. They appear when two different wave patterns crash into each other at 90 degrees. It often happens near peninsulas or land where two different seas or oceans meet. This phenomenon does kind of look spectacular, but only if you're watching it from the shore. Don't even think about getting in the water to play with such waves. Cross currents in that spot can easily pull even a skilled swimmer under the water. Square waves have caused many shipping accidents over the years, too. And if you see wild, choppy waves carrying ocean debris and seaweed, stay out of the water, too. It can be a sign of a strong rip current. That can carry you far away into the ocean. And now, let me tell you about a much larger, I would even say planet-wide phenomenon called Rossby waves. There are two kinds of such waves, oceanic and atmospheric. But since we're talking about ocean waves, yeah. Slow-moving Rossby waves are totally different from ocean surface waves. They don't look like those waves that break along the shore. No, Rossby waves are giant movements of the ocean stretching horizontally across the planet. They can span hundreds of miles in a western direction and are so massive they can change the climate conditions of our planet. They contribute to high tides and even flooding in some areas all over the world. The movement of Rossby waves are complicated and depend on the location. For example, in the Pacific, waves that are closer to the equator take from a few months to a year to travel across the ocean. At the same time, waves further away from the equator often need more than 10 years to make this journey. So, as it goes by, be sure to wave.
A trip to Hawaii may become your last. This is exactly what happened to David Potts, who came to Maui to spend some quality time with his girlfriend. We all know that the ocean can pose a whole bunch of dangers. Riptides, sharks, poisonous algae. Even a seemingly safe sand hole can end your life in a matter of seconds. Blowholes can do that too. The thing is, they're not frequently spoken of, therefore, many people just don't know that they'd better stay away from them. Now, let me break it down for you what a blowhole is. You all know sea caves, right? As any other formation, these grow in size. In case they grow landward and upward, they sort of turn into vertical shafts, exposing themselves toward the surface. As of now, everything seems fine, no extreme danger whatsoever, right? But the scary things start if those shafts begin getting hydraulic compression. In this case, seawater is released through a port right on top of the blowhole. The result looks like a geyser, and by the way, those blowholes even have a second name, marine geysers. The height of the spray may vary, and it's up to the geometry of the cave and blowhole, combined with tidal levels and swell conditions. So what exactly happened to David, who met his early demise in Hawaii? Those who were unlucky enough to witness this horrible incident said that Mr. Potts had been spotted dancing around one of those blowholes. He was dangerously close, just inches away from the opening. Moreover, some people claimed he had even been playing in the sprays of water that were shooting high into the sky. Then he suddenly disappeared into thin air. As it was discovered later, he fell into a blowhole. There were no official statements concerning whether Mr. Potts had passed away or not, yet he was never found, meaning his destiny is pretty much clear to everyone. The story took place back in 2011, so he's definitely not coming back, sadly. The big question is, who's responsible for this tragedy? There are no warning signs at the sign, so David could not know how dangerous that innocent fun was in reality. Moreover, witnesses claim it was slippery there, so it must have been an accident. However, despite most tourists knowing how notorious this area is, they still continue visiting the site. No tragic reminders help. So, how do you save yourself in case you come across a blowhole? The best way to do that is to keep as far away from it as possible. If you get sucked by it, your chances of surviving are virtually nil. Just for comparison, not every tsunami gives you chances this low. For instance, a 1-foot water level tsunami only gives you a 0.01% probability of passing away. Even a 3-foot water level, when you literally cannot stand on the ground, only says that the probability of passing away is high. Blowholes, on the contrary, don't give you any chances. They pull you in once and for all. But how do these terrifying holes actually work? Blowholes are most likely to form in places where there are crevices. A good example of a crevice is a lava tube. A lava tube, or you can also alternatively hear the name pyroduct, is a natural channel created by the movement of lava from a volcanic vent when it's traveling beneath the solidified exterior of a lava flow. When the lava within the tube drains away, it results in the formation of a cave. Those tubes can often be found along fault lines. A fault line is a flat fracture in the rock where significant displacement has occurred due to rock movement. Major faults in the Earth's crust are caused by tectonic forces, often forming at plate boundaries, like those found in subduction zones or transform faults. The rapid movement of these active faults generates most earthquakes, although some faults may shift slowly without causing seismic activity. It's known as aseismic creep. The next ingredient is powerful waves. When they hit the coast, water gets in those crevices. But since there's high pressure inside, it bursts out in the form of spray. To be honest, it's a whole show, as those water bursts are accompanied by a particular loud noise, which makes it very attractive for tourists. Sure thing, these formations do not only exist in Hawaii. Probably the most popular blowhole out there is located far away from Maui, in New South Wales, Australia. There's a small town of Kiama, and only around 15,000 people call it home. However, this small place attracts myriads of people because of a blowhole also nicknamed Kiama. This name has a meaning behind it. It's literally translated as where the sea makes a noise. And remember, blowholes are normally accompanied by a particular sound. The town of Kiama literally makes its living thanks to this unusual geological formation, attracting up to 900,000 tourists each year. There must be something special to see other than the hole, right? Otherwise, so many people wouldn't be ready to pay their hard-earned money to travel there. The blowhole in question can spray water up to 82 feet in the air. Trust me, if you come close to this place, you'll get thoroughly drenched in water. While this is not surprising, as we're dealing with the world's biggest blowhole here. Remember I told you, once you get into the blowhole, there's no coming back? It's not entirely true. Scott Gutterson actually ventured inside, studied the blowhole, and even found a secret chamber there. When he first went down to the bottom of Kiama, he found there a couple of bronze statues, some fishing rods, hats, a push bike, and even money. Still, you gotta remember that Mr. Gutterson is a professional, and you should never repeat his stunts. It's not the only blowhole that the town of Kiama has to offer. There's one called Little Blowhole, all because of its narrow shape. The good thing about it is that it's safer to visit than its big brother, but it can promise views as spectacular as the big blowhole. The brothers are a bit far away from each other though. The big one is just several feet away from the coastline, and the little one is around a mile south of the main blowhole. Sometimes there are fun legends behind those natural phenomena. You see, modern people can explain why water bursts from underneath the ground. We know the mechanics and logic behind it. But in olden times, people were way more superstitious, and it was not only easier to explain various phenomena as something supernatural, sometimes it was the only one explanation available due to the lack of knowledge and equipment. Thus, La Bufadora, a big blowhole in Mexico, got its beautiful legend. People used to believe that there was a whale trapped in the rocky point, and that the whale would blow water to attract the attention of its pod. With time, the whale turned to stone and remained there forever. Nobody definitely believes in it in the 21st century, but this legend helps attract tourists from all over the world, which locals are very happy about. You see, La Bufadora is located in a small town 17 miles south of Ensenada, and the blowhole helps create working places. Locals opened souvenir and food places, and at some point, there were about 150 active businesses not far away from the famous blowhole. You can often hear that people call La Bufadora a marine geyser, And while some blowholes can be referred to this way, this is not the case with La Bufadora. This one lacks thermal sources, and thus it can't be called a geyser. The water sprout here is the result of air trapped in a sea cave and forced upward. For it to happen, a wave must push the air into the cave. As a result, this wave is released in the form of water, recedes, creating that signature spray going upward. By the way, those sprays can reach up to 100 feet into the air. The sprays have their own time frequency too. It depends on multiple factors. But as for La Bufadora, the range between eruptions is 13 to 17 seconds.
It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific, and 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too. and create fences that will allow animals to reach higher ground.